Fascinated by pictures like this, you plunk down $2,000 for a new telescope, point it up to see for yourself, and it looks like this. You wonder, where did I go wrong? Oh, I know! A bigger lens and a reducer corrector should do it. So $300 later, and the image looked twice as good as this. Not half as good as this, twice as good as this. It doesn't take long to learn. You have to use a camera. Unfortunately, cameras for telescopes cost about the same as a telescope, or even more. Much more. You can shortcut the process using just a webcam, and immediately get images like this. There's software like K3CCD you can download for free, designed specifically to work with webcams to take astronomical pictures. That's how these were done. For pictures of faint things like galaxies and nebulas, you need to modify the webcam. Here's an example of how to turn a webcam into a long exposure Astrocam. A lot of people start with PVC parts, but there are no rules. This is a camera body made of 2-inch couplers and plugs. You need a part to connect the camera to the telescope. This one's aluminum. Here you see the cutout for the Peltier chip and the heatsink. These chips are actually refrigerators. One side gets hot, the other gets cold. The imaging chip heats up when it works, so you have to cool it to keep from ruining the picture. This is how you connect the refrigerator chip to the CCD imager. Mounted to the base, it looks like this. There are actually two cameras being built. You need to use a little thermal grease between the two parts. Notice here a heatsink with a fan has been attached for cooling the hot side of the Peltier chip. Add styrofoam insulation to cover the cold parts. The plastic ring will eventually support the imager. These T-rings and extensions connect the camera to the scope's reducer corrector. The chips get so cold, you have to purge the camera with Freon or CO2 or something inert to keep frost from forming over the CCD window. If you don't believe it, here it is turned on. Ice is formed on the tip where the CCD chip will go. This is the webcam motherboard. It's very small, 1 by 1 1/4 inch. The CCD is at the bottom. You have to unsolder and remove this part. Grind some perf board and gather some small wires for working with the CCD. You'll need to add extension wires to the CCD pins. Spread out a little to line up with the holes, thread the wires through, and level the window with the perf board. Solder the leads on the front side. These wires are really small. Make sure you always protect the CCD window with masking tape. Cover the back side and all the holes with more tape. Then run a piece of tape completely around the outside. You then pour epoxy into the taped area and let it cure. Drill the epoxy out of the mounting holes, but don't leave the CCD unprotected like this when you work. Sand the epoxy down to the level of the back side of the chip. It has to be even, all the way around. Thread the CCD wires through the camera base. Put the insulator and the CCD mount back in, and put thermal grease on the end of the cold finger. Screw the CCD holder to the mount, and tuck in all the wires. If everything goes all right, it'll look something like this. Here are some of the parts needed to make the Steve Chambers long exposure mod. You can find instructions on the web for all the different kinds of mods that can be made. This one is kind of old now. You probably won't make one of these. It's an SC 2.1 mod. Here's the 2U cam with the CCD removed and wires soldered to the USB connectors. I upgraded the original heatsink with this one. The cavity is for a temperature sensor. The enclosure for the SC mod board mounts to the side like this. Heat shrink and run the wires for hooking up into the box. The mod hasn't been done yet, but it's hooked up just to see if it all still works. Here the pin lift mod has finally been made to the webcam circuit board and protected with a layer of epoxy. And now the SC mod board itself is wired into the rest, then folded down with the cover ready to be installed. Altogether it looks like this, but this mod is 5 years old. Cameras and computers change so fast there are even better and easier ways of doing it now. I wanted to have a readout of the chip and heatsink temperatures, so I made these display boxes. I made them from these cheap electronic thermometers. They have two readouts. Unsolder the blue sensor and extend it using wires. The other one is already at the end of a long wire. You have to trim everything to make it fit into the project box. Here some of the plastic parts are being test fitted. Add connectors and put the circuit board into the box. Wire it all together in place. The black tube is the AAA battery it needs. The gray plug is the parallel port connector. The black one is for the USB. The blue cables connect the camera to the readout box. 12 volts for the cooling chip go in the side, and there's a switch for turning the readout on and off. There are also larger chips that can be substituted for the originals. Here's what one of them looks like in comparison. You make them the same way, but the wiring is a little different. You have to scramble the connection some for it to directly wire up. But if you do it right, it will go right in. These cameras have a wider field of view. These images were all made using those cameras. And here's an image of that nebula from the beginning. A vast and inexpensive improvement.